Did you know the APIC's database is broken up into 32 shards? You can think of shards as little mini databases. And each shard is actually replicated across 3 APICs. So here we can see shard 1 is replicated across APIC 1, 2, and 3. Now every single shard has a single APIC elected as its shard leader. So here is APIC 1 and it's been elected the leader for shard number 1. And maybe APIC number 2, it's been elected the shard leader for shard number 2. And determining the shard leader for the different shard IDs is deterministic, meaning APIC 1 is the shard leader for shard 1, and every shard ID incremented plus 3 thereafter. So that would be shard 1, 4, 7, so on and so forth. And APIC 2 is the shard leader for shard 2, and every shard ID plus 3 thereafter as well. And APIC 3 is the shard leader for the remaining shard IDs. Now you can find out who the shard leader is for a shard by running the ACI diag RV read command on any one of the APICs. And then what you want to do is specify one of the process IDs running on the APIC. So I'm just going to put in process ID number 3, but this number here, it's really not too significant. You can just use the number 3 as well. Next, I'm going to specify the shard ID number. So here I want to see who the shard leader is for shard 32. I hit enter. And here's our output. Now the output isn't too user intuitive, right? But we can see here that APIC number 2 is the shard leader for shard ID 32. Now if you want to find out who the shard leader is for a different shard ID, just put in a different ID other than shard 32. Now how does the shard leader concept come into play when configuring things in ACI? The configuration write requests are actually redirected to the shard leader. So for example, if you configure ACI from APIC 2, and let's say you make configuration changes to tenant 1, and tenant 1 resides on shard 1, APIC 2 will actually redirect the configuration request to APIC 1 because APIC 1 is the shard leader. APIC 1 would then commit the changes to shard 1, and then it would replicate the changes to the other APICs. Now, read requests can be handled by any APIC. So if you connect to APIC 2 and you're reading configuration data that resides on shard 1, this will be handled locally by APIC 2, even though it's not the shard leader for the shard. All right, I hope you understand a little bit more about APIC database sharding. That's all I got. I appreciate you.